All right, everybody, time to get into the next part of our lessons, and we are now going to start looking at the five types of reactions. Okay, so this goes into basically thinking about if you were to take all the chemical reactions ever known to man, or all of the reactions that ever could take place, you probably have a difficult time categorizing them. But we found a way to do this and basically put them into five general categories. Now, these categories, again, might not be every single reaction, again, but the simple reactions, reactions generally could be placed in these five categories. So let's start off with a simple one. Okay, so the first two are rather simply one, basic reactions, and one's called a synthesis. Okay, and the synthesis basically is when you take two compounds or an element or two elements or maybe even an element in a compound, and you create something new out of that by putting them together. All right, so a synthesis, or sometimes they even call this a combination reaction. So you can call it a combination, or synthesis can be both. All right, and again, we can see combinations or even a composition. Okay, and again, we like to joke around. I have these dancing people. I call this the dancing people page, and it's a good way to see maybe A is looking at a nice girl here, and he swings around and he dances with it, and you make a new couple out of this. So again, a little fun way to see how coming together, creating a new thing, is dealing with this. Just one thing you got to remember about a synthesis is that if you're synthesizing two elements, and again, this is just an example, that there is going to be a positive element, there's going to be a negative element. So again, when you write your formulas, you want to make sure this is correct. All right, so a synthesis. So some good examples of synthesis is you take an idea of an element, maybe nitrogen, and take a little bit of a hydrogen. You want to create ammonia, and these get together and create a new compound. So an element plus an element making a compound. And again, what we want to try to do here is balance these correctly. So two nitrogens here, you would need two nitrogens here, okay? And you have two hydrogens here. You have six hydrogens here. 2 times 3 is 6. So it's best to put a 3 in front of here, and that would be balanced. Okay. Don't forget on your balancing that your coefficients go for each element in the compound. All right. So that would be a correctly balanced synthesis type of reaction that would follow that form. Okay. Again, if you take calcium oxide and water and you put them together, you create calcium hydroxide. Okay. And again, in this case, you have a compound and a compound making a new compound. That can also happen when you have a synthesis reaction or a combination reaction. And in this case, one calcium, two oxygens. See, there's two oxygens here together on the side. That's balanced by the two oxygens there. So you're okay there. And now we have two hydrogens, and we are balanced by the two hydrogens there. So again, whenever you have a polyatomic ion in parentheses, remember that outside number goes for everything in the parentheses. So at this point, you are balanced across. You can either leave this the way it is, or you can then also, if you want to put your ones in here, you can. You don't have to do that. All right. And last is the creation of a new compound from two elements, where we'd have to write the new formula. Okay. So not always will you be given the entire reactions like this. You're going to eventually have to be able to create your own formulas and create your own product. So in this case, one thing you really have to understand and remember is that when elements are written alone in their unbonded state, sometimes they call this the free state. And the free state means that their charges are zero because they're starting in the neutral state. Okay. Again, even up here, you're going to be in your neutral state. Okay. So again, elements written by themselves have to be neutral. All right. This is before they bond. So of course, when they bond, they go into their electron transfer. All right. So because this is a metal, all right, and this is a non-metal, we're going to form an ionic bond here. Okay. And zinc, when it bonds, it becomes its ionic charge. So if you look that up in the periodic table, you will see zinc 2 plus. If you look sulfur up in the table, you will see the minus charge for sulfur is 2 minus. We are going to crisscross, and we are going to form ZNS. Okay, so very important. So you may want to get out your formula writing shoes. You may want to get out your polyatomic ions and start looking them up because you're going to need them going through, folks. All right, so zinc and sulfur become ZNS. Okay, just happens to be a little coincidence that we all have ones again, so it's not really a big deal bonding. Okay, so synthesis becomes this way. Well, what if we want to reverse this? And we look at the second one up here, the second little thing here. Maybe this guy, maybe upset his girlfriend. Okay, so that was synthesis letter A. Up here is scenario B. Maybe he's sitting with her and he said something nasty or something like that, or maybe she just doesn't like him anymore and she went and they broke up. All right, so she storms away all mad at him. That would be decomposing the relationship. So a decomposition is when you take A and B and you again separate them into two new substances. And again, sometimes this can be easy to see and sometimes not so easy. It depends on the reaction. All right, so the more of these that you do, the more that you'll see. Now, a couple things you want to be aware of. Okay, so here's NaCl breaking up into Na and Cl. It's the reverse. But remember, when elements are written alone, they're going to have the zero. One thing you want to watch here, watch your diatomic elements. Okay, diatomic, not spelling today. Diatomic elements must be written with the twos. Got to be careful. That 2 is going to have to be written. Notice up here with nitrogen and hydrogen that when you write them in your formulas, you're going to have to write those 2s. So we're going to go back to a little bit of your formula pain that we've had in the past. So just make sure you're paying attention to those formulas. It's really important to have right formulas. Okay? So in this case, we got 1 Na. 1 Na is good. You have 1 chlorine, 2 chlorines. We're going to have to put a 2 here and then balance that with the 2. Okay? Here's a reaction of taking peroxide. If we take peroxide, it decomposes into water and O2, okay? And again, we're looking at a heat on the right side, which is telling us that we're exothermic in this case, all right? And we want to be able to balance. So we take a look at this, okay, and we see that H and H is balanced, but then we have a 2 here, okay? And then we have a 2 here, but we have 3 oxygens here, and we have an oxygen here, which makes 3. So we have 2 on this side, but 3 on this side. A good way to take this and make it even is to even off those oxygens by putting a 2 here. All right. And what that does is gives us 4 hydrogens, and now it gives us 4 oxygens. So if we put a 2 here, we then balance everything. Okay. And it's always a good idea to go back over and say, okay, what do we really do? Can we go 2 times 2 is 4. 2 times 2 is 4. 2 times the oxygen is 4. And now you have 2 here, plus these 2 is also 4. So now we're balanced. All right, so you want to be careful here on when you decompose. You don't always decompose into elements. Sometimes you decompose from a compound into 2 smaller compounds. And again, that just comes from experience. All right, important to know. Okay, so again, aluminum oxide is an interesting one. Okay, what are we going to do here? We have to figure out what to do. So what we're going to find, okay, is that aluminum and oxygen. Well, what do we do with this when we decompose it? Okay, the best option is just to simply decompose it into its elements. So what 2 elements are in aluminum oxide? Well, we have aluminum, okay, and we have oxygen, right? Those 2 elements. And now we want to take a look and ask yourself the question, did I write the correct formulas? Is the correct formula for aluminum Al? Yes, it is. It's a metal, right? Is the correct formula for oxygen O? Well, remember, oxygen is a Brinkelhoff, so we have to write that with a 2 here. Very important. Okay. Once that step is done, okay, now you can correctly balance. You have to have correct formula. It's really important. All right. So we're going to take 2 aluminums here, 2 aluminums there. Okay, looks pretty good. Okay, 3 oxygens here and 2 oxygens here. My correct multiple, my good multiple for 2 and 3 is going to be 6. So if I create 6 on one side and 6 on the other, that should do it. So I'm going to put a 3 here. That's going to give me 6 oxygens. I'm going to put a 2 here. That's going to give me 6 oxygens. However, I just messed up my aluminums. Now I have 4 aluminums here. So I'm going to have to scratch this out and make that 4 aluminums here. So my correct coefficients would be 2, 4, and 3. Okay? So again, synthesis is putting things together. Decomposition is taking them apart. Okay? All right. And a couple things you want to remember is that elements and diatomic elements written alone have oxidation numbers. Again, the oxidation numbers are your charges, okay, equal to neutral. Really important that you know that. Only when they're in bonds do they have their charges. Okay? And very important, make sure all formulas are written correctly. Okay, that's going to be a really important thing to do when we go back over. So again, check your polyatomic ions, check everything that you need to do, okay, and be able to not be able to memorize what these are, be able to look at them and say, okay, I see one thing and a second thing becoming a third thing. I see these two things getting together to form one thing. I see these things getting together to form one thing. When you look at a decomposition, take a look and see how it's breaking down or breaking up. Okay, really important on what to do there. All right, so I know this is a little bit of a shorter one. They get more complicated as we go, but that is a synthesis and a decomposition. We'll talk to you soon.